special sequences called arithmetic sequences. Let me give you an example of an arithmetic sequence. 12, 14, 16, 18, 20, 22, and on it goes. And notice what makes this special is that to get from one term to the next, you always add the same number. So from 12 to 14, we'd add 2, and then we'd add 2 again, and again, and again, and again. And another way to say that is that the difference between any two consecutive terms is the same. 14 minus 12 is 2. 16 minus 14 is 2. 22 minus 20 is 2. So there is a common difference between any two consecutive terms. So we use that when we're talking about arithmetic sequences, because every arithmetic sequence would have what we actually call a common difference. How about if I spell that correctly? Whoop, that looks sloppy, but that says common difference. And we generally let D represent the common difference. So for this problem, the common difference is 2. Let's do another one. Here's the sequence: 0, 1/2, 1, 3/2, 2, and so on. Now you can confirm that this is arithmetic. Look, that when we start at 0, you can add a half to get a half. Add another half and you're at 1. Add another half and you're at 1.5 or 3/2. And again, the common difference is 1/2. 1 minus a half is a half. 1/2 minus 0 is a half. So we would say D equals 1/2. We could have a sequence that looks like this: 15, 11, 7, 3, -1, -5, and on it goes. I hope you can see the number that you would add, or maybe you feel like you're subtracting, but we know subtracting, in this case 4, is equivalent to adding -4. And look, we add -4, add -4, add -4, or if you prefer, subtract 4. So we would say the common difference here is -4. And again, remember, we call it a common difference because you can take any two consecutive terms and subtract 3 minus 7, and you would get that value. So let's look at this particular sequence. We can confirm that it's arithmetic by subtracting consecutive terms. 11 minus 6 is 5. 16 minus 11 is 5. 21 minus 16 is 5, and so on. So the question here is to find, remember this is our notation for the 6th term and the 20th term. Well, we have the first term, second term, third term, fourth term, fifth term. The 6th term is just the next one. So I hope you see we could just take the 26, add 5 another time, and we would just have the 6th term as 31. But now to get to the 20th term, I don't want to just keep adding 5, adding 5, adding 5 until I get to the 20th term. I want to come back and look at how the terms are related. Notice this first term is 6. And the second term, right here, we can obtain by starting with 6 and adding 5. Let's get to the third term. The third term you can obtain by starting back at 6 and adding 5, right? I am adding 5 to get here and adding 5 to get to the third term. Notice to get to the third term, I would add in the 5 twice. So I'd have 6 plus 2 times 5. Now, if I wanted to get to the fourth term, I could start at 6. And notice I would need to add in 5 another time. So to get to the fourth term, I would start with the 6 and add in 5 3 times. And similarly, to get to the fifth term, I would add in 5 4 times. So conveniently, we have this nice pattern here. So I hope you can envision what would happen if we went all the way out to the 20th term. For the 20th term, we would start with 6 and add in 5 19 times. And we could do the arithmetic there. Let me just move over here. So the 20th term is obtained by starting with the first term and adding in our common difference 19 times. So we have 95 times, or 95 plus 6, or 101. So the 20th term in this sequence, way over here, would be 101. So let's look at what that means in general. Let's take this arithmetic sequence. I've just listed terms of a sequence, right? And I'm just saying this one's arithmetic. That means there is a common difference, which is D. So this first term right here will just be a sub 1. But this term right here, a sub 2, will be the first term with D added in. This third term will be the first term with D added in twice. The fourth term will be the first term with D added in 3 times. And if we continue, what we'll find is this nth term. Here's the important part. The nth term can be found by writing or finding the first term and adding in D n minus 1 times. Right? The coefficient of D will be 1 less than the term number you're on. So let's write that big so we make sure we know what it is. The nth term of an arithmetic sequence is always the first term plus n minus 1 times D. That's an important formula for us to know and keep in mind. Keep in mind that it is only valid if the sequence is arithmetic. So let's look at our next problem. So here's our sequence: 400, 397, 394, 391. Before we can use our formula, we need to confirm that it's arithmetic. So notice if to get from 400 to 397, we'd subtract 3 again, subtract 3 again. So we can find that our common difference is -3. So we have confirmed that it's arithmetic. So now we can use the formula to find the 42nd term in the sequence. So let's write the formula down. A sub n equals a sub 1 plus n minus 1 times D. So the 42nd term is found by starting with the first term, which is 400, plus n minus 1, n is 42, times D, which is -3. So let me just simplify this part right here. 400 plus 41 times -3. So looking at this formula, we start with the first term and we're adding in D 41 times because we're getting to the 42nd term. So if we do our arithmetic here, we have negative 123. So the 42nd term is equal to, what is that, 277. So way down here, if we kept writing, and when we got to the 42nd term, it would be 277. Now let's see if we can find the nth term. I should have left a little more space. Let's see if we can squeeze it in. We already have the formula written. Let's write it again. So when you're asked to find a sub n, you're being asked for the formula that represents the nth term. So we start with the first term, which is 400, plus n minus 1 times d in this case, which is negative 3. And sometimes people just present the answer like this, but I'm going to keep going. We have a sub n equals 400. And then we're going to distribute negative 3. So I have negative 3n plus 3. So I have a sub n, or the nth term of this particular sequence, can be found by using this formula. Negative 3n plus 403. And in fact, if I hadn't already found the 42nd term, I could just have put in 42 right here. You could put in any number you'd like. You need the 1000th term, put in a 1000 right here, and you'll find that term in this particular sequence. Let's continue. If we're going to use the formula that relates terms of a sequence for arithmetic sequences, it's important to recognize whether you have an arithmetic sequence or not. So let's look at a few sequences and just focus on whether they're arithmetic or not arithmetic. So let's look at the first one. 2, 5, 6, 9, 10, 13, 14, and so on. Notice to get from the first term to the second term, you add 3, and then you'd add 1, then you'd add 3, and then you'd add 1, then you'd add 3, and then you'd add 1. So there's this nice pattern, but just because there's a pattern doesn't mean that it's arithmetic. In fact, we know that it's not arithmetic because the difference wasn't common. Here the difference is 3, here the difference is 1. I didn't even need to continue. As soon as you see that you have two different differences, there is no common difference, and we know it's not arithmetic. Again, because the distance here is 3, or the difference is 3, and here the difference is just 1. That's enough to know it's not arithmetic. Let's look at the next one. 1/2, 1/3, 1/4, 1/5, 1/6. It's a nice sequence. But is it arithmetic? So our test is to look for the difference between two consecutive terms. And let me just start with these two. So let's look at 1/3 minus 1/2. Now, if I get a common denominator of 6, I would have 2/6 minus 3/6. That's negative 1/6. Okay, so the difference between these two is negative 1/6. Let's look at the difference between the next two. 1/4 minus 1/3. Common denominator here is 12. So we have 3/12 minus 4/12. and that's negative 1/12. So again, we see that we do not have a common difference. So this one is not arithmetic either. Let's look at a third one. And the question is still the same. Is the sequence arithmetic or not arithmetic? And so here it is. 2 square root of 7, 3 square root of 7, 4 square root of 7, 5 square root of 7, and so on. And again, remember the test is to see whether the difference between consecutive terms is common throughout the sequence. So we can test. Let's look at 3 square root of 7 minus 2 square root of 7. Well, we know 3 square root of 7 minus 2 square root of 7 is 1 square root of 7. Similarly, 4 square root of 7 minus 3 square root of 7. We have 4 minus 3. We're subtracting those coefficients. So 4 minus 3 is 1, and we have 1 square root of 7. Similarly, 5 square root of 7 minus 4 square root of 7 is square root of 7. So we see we do have a common difference for this problem. So this one is arithmetic. So let's do a little bit more with this problem. I didn't ask you to do anything aside from determining whether it's arithmetic, but let's just find the formula that represents the nth term for this particular sequence. We know because it's arithmetic that this formula is valid. A sub n equals a sub 1 plus n minus 1 times d. So the nth term can be found by starting with the first term, which is 2 square root of 7, and adding in d n minus 1 times. So we'll leave the n minus 1, but we know d was equal to square root of 7. Right here, this tells us that d equals the square root of 7. So let's just put that square root of 7 right here. And I'm going to distribute that square root of 7. So we have a sub n equals 2 square root of 7 plus n square root of 7 minus the square root of 7. And I'm going to combine these two. So I have a sub n equals, let's write the n squared of 7 first. And 2 square root of 7 minus 1 square root of 7 is just 1 square root of 7. Now that could be where we stop. I just want to show you one more thing right here. Let's just go one more step for this particular problem. I'm going to factor out that square root of 7. So if I do, I'm going to factor out the square root of 7 and I'm going to put it after this binomial. I would have n plus 1. The coefficient of that square root of 7 is 1. And notice what that tells us. If you were going to look for the fourth term, for example, you would have 4 plus 1 or 5 square root of 7. Notice we can confirm right here, fourth term is 5 square root of 7. So we have some confidence that that is in fact the formula for the nth term. Let's do one more problem. It will look like this. Suppose if we have an arithmetic sequence and we're not given the first term, we're provided with the fifth term and the 15th term, and our task is to find a formula for the nth term. And for good measure, once we find that formula, why don't we find the 426th term of the sequence? So understand what this means. Let me just draw some lines that represent terms of the sequence. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the information that we were provided with says this fifth term right here is 27. Right? We have a list of numbers. And this 15th term right here is 52. And our task is to come up with the formula that represents the nth term. So we could find any term in the sequence, starting with the first term and going however high we would like. Well, keep in mind, since it's arithmetic, we know this will hold for the sequence. The nth term is equal to the first term plus n minus 1 times d. So let's write an equation that uses that information, this information with this formula. So just based on this, we know the 5th term is the first term, right? First term is right here. We don't know what the value of it is, but there's our first term, plus n minus 1. N is 5, so n minus 1 is 4, times d. And in fact, we know the 5th term is 27. So we know for this sequence, 27 equals a sub 1 plus 4d. Now, similarly, let's look at our 15th term, which we know is 52. The 15th term can be found by starting with the first term and adding in d 14 times. So with this information, we know 52 equals a sub 1 plus 14d. Now look what we have. We have two equations, and they each have two unknowns, so we can put those two together, and we have a system to solve. So let's solve that system. I need to move to a new piece of paper, but we'll solve this system. Let's move up this way. Remember, you can use any strategy you like to solve that system. Elimination or substitution would both work well. Now you could multiply this equation by -1 and add to eliminate. That's what I'll do. But let me also point out, it is totally valid to just subtract the two equations. If you're comfortable doing that, go ahead. But let me continue doing what I suggested. Multiply by -1. So I'd have -27 equals -a sub 1 minus 4d. And 52 equals a sub 1 plus 14d. And when I add those two equations, I have 25 equals 10d, or d equals 25 over 10, which is 5/2, or 2.5. That's an exact value, 2.5. I think I'll leave it as 2.5. To finish solving the system, now I have d. I can substitute that back into one of the original equations. So 27 equals a sub 1 plus 4 times 2.5. That's 27 equals a sub 1 plus 10, or a sub 1 equals 17. So after solving this system, what I now know, back over here, is that this term right here is known now to be 17. And the common difference for this problem, common difference is 2.5. So to get from the first term to the second term, I would add 2.5 and then another 2.5 and plus 2.5 throughout the sequence. What was the question? Find a sub n and a sub 426. So let's do that. What's the information that we need to find that formula? If we know that a sub n equals, let's write out our formula. We have a sub n equals a sub 1 plus n minus 1 times d. We're trying to find a sub n. Our first term, remember, is now known to be 17 plus n minus 1 times d. Remember, we found d, and d is 2.5. So if we distribute, we have 17 plus 2.5n minus 2.5, or the nth term is 14.5 plus 2.5n, and I actually prefer to write the term with the n first, so let me do that. 2.5n plus 14.5. So here is our nth term for the sequence that was described right here. And if you're doing a problem, you could confirm that you have it correct. Pop in a 5, make sure you get 27. Pop in 15, make sure you get 52. The last part of the question was to find the 426th term. So here's our formula we just created. So a sub 426 is 2.5 times 426 plus 14.5. And let's punch that in on our calculator. So we have 426 times 2.5, which is 1,065, plus 14.5, and we get 1,079.5. So it's nice we didn't have to go one by one to get to the 426th term. We know for this particular sequence, if we went way down there to the 426th term, we would see that the term was equal to 1,079.5.